Good morning, everyone. Welcome to Soil Science Seminar. I'm delighted to introduce our speaker today. Our speaker is Professor Michael Thompson, who's been on our faculty since 1980. But to go backwards, Dr. Thompson is a native of Illinois. In fact, I just learned he split his time growing up between El Dorado, which I was mispronouncing earlier, and Peoria, Illinois. And then his baccalaureate degree is from University of Illinois, Urbana-Champaign. Following graduation there in 1974, he went to The Ohio State University for his PhD. The topic of his PhD was frangipane soils. The frangipane soils of Jackson Valley. Excuse me, frangipane soils in the Taze River Valley of Jackson County, Ohio. More or less, that's right. Which is a really interesting dissertation. I'd actually looked at it when I was at Ohio State myself. But anyway, a wonderful dissertation. Following his completion of his PhD, he joined the Iowa State faculty. He began as a pedologist. He was very, very active in the soil survey program here in Iowa. And then after a few years, he switched to working in soil chemistry. Both have created great success for Dr. Thompson. He's a fellow in the American Society of Agronomy. American Society of Agronomy. He's a fellow in the Soil Science Society of America, and he's also a fellow in the American Association for the Advancement of Science. On top of that, of course, he's also president of the Soil Science Society of America Society. So I'm delighted to have Dr. Thompson here as our speaker. So Michael, please.
Thank you, Lee. Thank you all for getting up so early to be here. If you read the title of my talk that was published, forget it, because I'm not going to adhere to that title. Here's the title: Random Reflections, and basically I'm just going to talk a little bit about why I'm a soil scientist, what soil science means to me. Very free form. Okay, so why am I a soil scientist? I thought that might be a good thing for me to reflect on and to share with you some of my motivations for being here at Iowa State, sticking it out for 43 years as a soil scientist. So I'm going to tell you some stories, personal stories, or personal in a sense, stories about why I am a soil scientist. So I'll start out there. The basic reason is because of my grandparents. My grandparents, on my mother's side, Paul and Marion Trevelyan, were farmers in southern Illinois. Granddaddy had grown up on a farm, and in 1918, like hours before he left to join the American Expeditionary Force in France in World War I, he and my grandmother got married. I mean, hours before he got on the train, they decided to get married. He was in France for 10 months or so. Fortunately, he didn't see combat, but when he came back to the United States, he was walking with two canes because he contracted mumps and spinal meningitis simultaneously while he was in France. Fortunately, he recovered. He and grandmother started a family, and in 1920 he decided he needed more education. He had not graduated from high school, but perhaps, I'm speculating here, but perhaps his trip to Europe, kind of seeing the rest of the world, had an impact on him. And he decided he needed more education. So he applied to the University of Illinois to become a college student. Well, they didn't really want to accept somebody without a high school diploma, but somehow he convinced them that he was okay. I think maybe they had kind of some form of a GI Bill at that time as well. So he and grandmother moved 200 miles north up to Urbana for him to get an education, which 5 years later, well, 1925, he graduated with a bachelor's degree in horticulture. He turned down an offer of an assistantship to stay around to work on a master's degree because he wanted to get back to the farm with his family. By that point, there were 2 sons. And so they moved back down to southern Illinois, bought a small farm and began farming. Now, his degree was in horticulture. What he wanted to do was to raise apples and peaches, which at that time was that part of the world was ideal for raising apples and peaches. Climate has changed a little bit today from what it was then, but at that time it was ideal. So they returned to southern Illinois and started their business. Now, when he returned to that county, that very southeastern county of Illinois, right along the Ohio River, I am speculating again, but I think he was probably, you could count the number of people in that county who had a bachelor's degree on one hand. I'm pretty darn sure. And so he was an unusual person to be a farmer, to have a degree, and to be farming. Well, his grandfather had come to that part of Illinois in the 1850s from Tennessee. That family, the family of Trevilians, had migrated north from Tennessee to buy new farmland and to start churches. It was really a religious calling, if anything, for the family to move northward to that part of southern Illinois. Now, this was after 1850. This was after the indigenous people in that part of Illinois had been displaced. But that family got started. They built churches. They started multiple small farms. And as I was a child, spending my time in that county in southeastern Illinois, I learned all the stories of my grandfather, his father and mother, his grandfather and mother. I learned that stories. I saw the continuity of family, and all of those folks were buried in a cemetery that I would go visit with my family. So I felt very much connected to the family, and also with all the church activities that we did. The homestead where my grandfather and grandmother settled was at the summit. It was on a summit position above a valley. So it's like maybe a 200-foot bluff from the farmstead up on the summit to a valley. That valley is about 10 miles wide. It is a big valley. It's not the valley of the Ohio River, but it is the valley where the Ohio River flowed during glacial periods. When the eastern part of the United States was covered with ice, and as the ice melted, all the meltwater would come down the Ohio River. It came down through part of what is today's Ohio River, but close to where the farm was, the river changed course and created this valley below where the farm is. It's called the Cache River Valley. It's a swath of glacial sediments, very sandy soils that define the landscape. Well, the other thing that defines the landscape in that area is the bedrock, which were Mississippian sandstones largely, had been exposed as the Ozark Mountains rose and eroded away. The topography in that area, even up on the summit of the bluff, is really rugged and dissected. So the farm sits up here above this magnificent valley, highly dissected, eroded landscape above, but the soils on which the farm was located were not derived from sandstone paramaterials. Instead, they were derived from something that we are familiar with here in Iowa, silt, wind-blown loess. In fact, multiple deposits of loess sitting on top of the dissected sandstones of the uplands. Those multiple deposits of loess contained these unusual horizons which limited the movement of water and roots, horizons called fragipans. And the fragipans had an impact on the productivity of the soils, and particularly how far the roots from the apple and peach trees could penetrate and survive. So my grandfather was quite interested in soils on which the farm lay and how they influenced his agricultural practices. Okay, now when I was 10, which was in 1962, the Illinois Geological Survey ran a field trip through that part of southern Illinois. They used to do this all the time, all over the state. Field trips like these caravan field trips where they invite anybody who wants to go on a field trip, and you get in a line of cars and you snake around up and down the gravel or dirt roads and stop periodically and have geologists tell you what you're looking at. So Granddaddy had his grandchildren, he being one of them, go on this field trip, the geological field trip, to learn about those Mississippian sandstones and the Cache River Valley and the loess deposits on top. And I was really fascinated. I was just so fascinated. And well, it didn't hurt that we had some stops at some quarries so that I could hunt fossils and pick out these really cool fossils of organisms that had survived long enough to be buried by the marine sediments in a shallow sea hundreds of millions of years ago. And today I was seeing them as I was digging them out of the sediments. So that got me interested. I had an interest in agriculture because of the connection to the family and the farm. I had an interest in geology, which was spawned by that field trip, but also by the fact that my grandfather took us there. He wanted us to know. He wanted us to know more about the landscape that he lived in. Now, the farm was also located, besides being on the top of a bluff, it was located about a mile from an old stagecoach road that crossed southern Illinois from Kentucky to Missouri, or I had been there for 100 years or so. That stagecoach road had been the path of, maybe you're familiar with this, the Cherokee Trail of Tears. When the Cherokee Nation was forcibly removed from North Carolina and forced to travel to Oklahoma. One of many episodes in our nation's history that are difficult to understand and understand in history. But that farm was just a mile away from the Trail of Tears. Well, we knew about the indigenous people who had lived in that area because my grandfather, I mean, he was born in 1895, but throughout his life, as he traveled in the county, he found artifacts of the people who had lived there before, grinding stones and mortars and pestles, projectile points. I found some when I was walking around as well. So we knew that people had lived there before the European settlers. And we also knew about this tragic story of indigenous people crossing just a mile from our farm, and how many lives were lost along that way. So we had a sense of history. I think that's the main thing I'm trying to say. We had what Granddaddy was helping me see, I think, was the importance of understanding my place in a family, in a place, in a time, and to understand the continuity of the stories that would define, my future. Okay, so Granddaddy and soil. I want to say a couple more things about Granddaddy and soil. Of course, the soils on the farm were the foundation of his orchards. He had seen a lot of soil erosion in the 1920s, 30s, 40s. In the 1950s, when the Soil Conservation Service was really ramping up its national programs after World War II, and Soil Conservation Service ramped up national programs, they promoted the concept of soil stewardship. Now, that really rang a bell for my grandfather because it connected what he worked with daily on the soils on his farm and his religious perspective about the earth being created by an all-powerful creator, and that we were here on earth to steward the resources that we were given. And so he got quite involved in the soil conservation effort in the 1950s and 1960s. He was one of the leaders of the Illinois Association of Soil Conservation Districts. We do have soil conservation districts in Iowa yet. You might not know that, but we do. They're extremely important. So he was a leader in the soil conservation effort, and I knew about that as a child growing up. So my grandparents had 4 children, 2 sons and 2 daughters. The 2 daughters both became teachers. Unfortunately, there weren't so many professions available to women at that time other than teaching, but they became teachers. One of the sons became a large animal veterinarian working in that county and surrounding counties, connected to that place. And the other son, the eldest son, became a district conservationist for the Soil Conservation Service, working in southern Illinois. So I had, as I grew up, I had all of these people who were telling me about what was important in their lives, and that helped me choose the things that were important in my life. So the imprints on me, I know this is a long story, but this is the story I want to tell. Those imprints on me include the idea that agriculture is a noble profession and it's vital for the care of the earth, along with stewardship of all the resources on the earth. And that grew out of a spiritual or religious connection, not only with the land, but with people who live there now and the people who had lived there in the past as well. Another thing that was imprinted on me was the significance and importance of education. My grandfather had a college degree when a tiny fraction of the people in the United States had college degrees. My parents' generation had college degrees. I was expected to go to college. Nobody thought I would get a PhD. What does that mean? But anyway, I took it one step further. And then that little section of southern Illinois, the very southeastern corner, not too far from where the Ohio River meets the Mississippi River near Cairo, that place had a history. It had a history that was decades old, decades that my grandparents were farming there. It had a history that was hundreds of years old with my grandparents' families that had come there to settle. It had a history that was centuries old of the indigenous people who had lived there before. And it had a history of millions of years, time enough for those lust deposits to sit on top of already deeply eroded sandstones that had been uplifted from marine sediments. You know, it's a long history, but it was all connected. And so I felt a part of that through the stories. So stories are a really important part of the answer to why I am a soil scientist. Now I'm going to shift. I want you to keep that in mind, but I'm going to shift to talking about science in general for a second. I have an idea. Okay, so I already told you, know this, Lee told you, I have a PhD in soil science. Well, I interpret that to mean doctor of philosophy, so I'm allowed to philosophize. That's what that means. So I'm going to talk about science philosophy for a minute and what I think science is. I think that science is primarily an effort to systematically identify and interpret patterns. Patterns is the key word. Now, humans identify patterns all the time. That's what our brains do naturally. That's typical. What's different about science is we try to do it systematically, where we set up hypotheses and test hypotheses and change our hypotheses and try to improve our understanding of those patterns over time. Understanding those patterns is a key, not only to tell us what happened in the past, but of course to help us predict what might happen in the future. I mean, to me, that's what science is all about. And so that's a story. We're creating stories of the past and predicting stories for the future with the science that we do. And if our eyes and ears and other senses are open, we perceive great beauty in the patterns that we observe. Well, what do I mean by beauty? Okay, now even more philosophy. What is beauty? This is called aesthetics by the professional philosophers. So I'm not a professional philosopher. So what I'm going to tell you, my thoughts about beauty are purely personal and naive. Believe me, it's going to connect to soil in a minute, so just hang on. I think there are multiple kinds of beauty, And if you want to read more about it, actually, if you read this month's issue of CSA News, you'll see I wrote a column about beauty, which is going to go into more detail than I'm going to get into right now. But here are a couple of types of beauty: sensory beauty, the kinds of things that we perceive with our eyes or our ears or our sense of touch, or taste. What aspects of sensory beauty evoke these sensory perceptions evoke a sense of beauty in me? Here are some examples: the symmetry, the shape of what I'm looking at, a sense of proportion or balance in the thing that I'm perceiving, whether it's continuous or discontinuous, the light that is shown on it, or the light that it emits, its diversity, its variety, and also its harmony. Some of you know that I mean, I'm not a musician, but I do love music, and there are all kinds of harmony, all kinds of ways of thinking about what harmony is. Some of the beauty that I perceive as beautiful, things that I perceive as beautiful because they mean something to me. They are patterns that are continuous with other patterns that I already know, that I'm familiar with, and that I recognize something that helps make it beautiful. But some of those things will still give me new insights, help me make new predictions. They'll have a story to tell me, and there will be a sense of mystery, things that I don't understand about what I'm looking at or seeing or hearing or touching. So those are all aspects of beauty. Now, when I went to the Ohio State University, my mentor there, Neil Smeck, had done some work in soil micromorphology, and this was brand new to me. I was really captivated with the idea of looking at soils through a microscope and seeing soils at a scale that I had never imagined before. So I'm going to show you some images now drawn from a workbook that I put together last fall for a workshop on soil micromorphology at the SSSA meetings in St. Louis. And I'm not going to tell you very much about what these images represent scientifically. I'm just going to ask you to look at the images and imagine what you see. You may not think they're beautiful. That's not, don't worry about that word, but what do you see? You probably see shape, and you see colors. You can think about the proportion of the objects in the image, whether they're symmetrical or asymmetrical. Perhaps you can imagine a story behind each of those objects, how they got there, how they have changed over time. So here is an example. These are images of minerals like calcite or biotite, muscovite in the soil. Here are some images of what occurs in A horizons of soils in Iowa. I should have blown these up so you can see them in much more detail, but perhaps you can see the fine aggregates. Officially, we call them PEDs. And you can see a decomposing leaf that's been chewed up by an insect and starting to decompose. You can see charcoal fragments. Here are some images of minerals that occur in subsurface horizons. On the far left is we call it micritic calcite. You know what calcite is, calcium carbonate. These are extremely fine precipitates of calcite. In the lower left, we've got those orange yellow streaks of layer silicate clay that are embedded in a matrix, and you can see the dark brown zone in the lower right-hand corner of the image in the lower left, which is an accumulation of iron oxides. On the lower right, you've got fecal pellets. You know, there was a time when I was an expert in fecal pellets. I could distinguish, actually, I'm still
You're an expert, yeah.
at distinguishing. Okay, anybody can distinguish earthworm fecal pellets from potworm fecal pellets. But distinguishing the Inca triads from the collembola, the springtails, those pellets that's a little different. Or the pellets that fly larvae that are living in the soil, they have a distinct kind of pellet. All of which create the granular structure that we see in our soils that we call PEDs. Okay, so now what I'm doing is I'm showing you images of things that have stories. They're colorful, they have shapes, they're maybe symmetrical, maybe not, but the combination of the stories and the images are, for me, a beautiful combination of sensory and meaningful beauty. Okay, now maybe you've seen an image like the one on the left before. That is an image taken by the Hubble Space Telescope. It is it's called the Small Magellanic Cloud. It's a satellite galaxy of the Milky Way.
I messed up. Mister.
That
Mister.
we are a part of the Milky Way galaxy. This is about 210,000 light years away. If you've ever seen any of those space telescope images, I'm sure you've thought stunning, beautiful, incredible. Okay, well, I've juxtaposed it with an image from a typic RGL ball in Iowa. It's the BTG horizon. So what does that tell you? It's a subsurface horizon with an accumulation of clay. It's glade, so it's a high water table. There's been fluctuation a lot, and deposition of iron oxides. To me, it's a beautiful image as well. So just to go back to remind you, beauty, it's all in the eye of the beholder, of course. You may not see these things in terms of these kinds of images as beautiful images in the way that I do, but I would invite you to think about the beauty in all the things around you from this perspective of what you're sensing, the shape, the color, the light, the touch, and the stories that illuminate history, and the mystery, the history and the mystery of all the things that are around us, including soils. Okay, so now I'm not quite done, but I'm going to give this is a conclusion for this part of my talk. Okay. Why am I a soil scientist? Inspiration of my family, the connection to agriculture, a sense of belonging to a place and a time, a conviction that we are only stewards of the land. We are not owners, but we are stewards of the land. I'm a soil scientist because I love stories and history. Some of those stories are personal. Some of them are epic, like over hundreds of millions of years. And because I appreciate the beauty and the presence of soils. Okay, now I'm going to change gears, but I'm going to stick with the soil science theme. What is soil science? Now, this, I think you'll probably find something to agree with and perhaps something to disagree with as well. But soil science is a multitude, I think, of sub-disciplines that are focused on soil. There are all kinds of applications of soil science, and those of you in this room and online are familiar with all kinds of applications, and not only familiar with experts in disciplines like cropland soils or urban soils or forest soils, or maybe you're an expert in soil classification or informatics, or maybe soil fertility, or organic matter, or you're interested in the environmental aspects of soils, like how soils can be eroded or transport contaminants. Okay, to me, all those things I would call applied soil science, which rest on a bedrock foundation of disciplines, the four foundational disciplines of soil science, which are soil morphology and genesis, soil chemistry, soil physics, and soil biology. Those are the foundations on which the wonderful applications of soil science are built. Now, my work at Iowa State has been quite varied, and I've just got a list of some of the things I've worked on so far in the time I've been at ISU. My research has always been in collaboration with colleagues who have taught me enormously. So I've done work on quaternary paleosols, on the genesis of mollic and RGL balls in Iowa. I've done some work on potassium availability to plants. Considerable effort on the characterization of soil organic matter and how residues decompose and are incorporated into soil organic matter, how carbon accumulates in the soil. Some work on both natural char and manufactured biochar. Quite a number of studies on phosphorus and the environmental soil science, soil contaminants. I've worked on copper, zinc, lead, actinides like americium and plutonium, endocrine disrupting compounds that end up in the soil because of waste products that end up in the soil. I have over the years taught a variety of courses, starting out, as Lee said, in morphology and genesis. The first course I taught when I arrived at Iowa State University had a wonderful group of students who, as usual, taught me more than I taught them, but one of them was that guy sitting right there.
No, I really got through it, but thank you, Mike.
I taught clay mineralogy, soil chemistry, soil plant relationships for a couple of years. I've been teaching now for 13 years, organic compounds in plants and soils, undergraduate course. And I also have taught courses over several years in ethical decision-making science. So, you know, I like to teach, but why? I like to teach because I like to learn, you know? I mean, ultimately that's the real motivation. I want to share with students what I know if I can. But every time I teach a course, I learn something. And so that's why I'm an academic, because I like to learn new things. The other thing I would say about the last 43 years is I've done some international work, which has been really important, not for me for me personally, but I hope it's been important in other ways too. I've collaborated with soil science colleagues in France and Brazil and China. I was fortunate to be able to live for 10 months in France, during which time I learned French for a couple of years before that, but it wasn't until I actually lived in France that I learned how to speak and listen in French. But that was so important to me, to learn another language, to learn not only to speak it, to listen, to think in French, to dream in French. That had a big impact on me. And those of you who are in this room who speak more than one language, you know what I'm talking about, how significant that can be. Of course, working with colleagues in other countries meant that I had to expand my ideas about soils. So I learned to respect the perspectives on soil science that folks who came to soil science with a different set of motivations and assumptions than I had. I had to learn to respect that and learn from it. And I can't say enough about how important my collaborations have been with my graduate students who have come from all over the world. It's been so enriching, so enriching. So now I'd like to tell you, if soil science is to survive, and the reasons I won't delve into right now, I'm starting to question whether that is a surety. But if it's to survive, I think we need to continue to be interdisciplinary, connecting what we do to other disciplines in science and engineering. We have to strengthen our applications of soil science, all those wonderful applications. But at the same time, I'll say strengthen the applications, look for opportunities to work with international partners. That's, I think, super important for us here in Iowa. We're landlocked in this one little spot on Earth. We have to find ways to connect with people around the world and develop new collaborations, not just with traditional scientists, social scientists, economists, with philosophers, with musicians, with artists. We can collaborate with these folks to tell the stories of our science and how we understand the world through our science. And here's the last point. Please believe me, I think we've got to keep those 4 foundations of soil science strong, because that's where all those applications rest on the foundations. So I advocate for the Warrior II pose. I'm not an avid yoga practitioner, but occasionally I have practiced yoga, and I love this pose. It is a pose of strength. It's a pose where I won't be able to do it perfectly, but we're reaching back to touch the past. We're firmly grounded in the present, but we're also reaching out to the future. And I hope that's what soil science can be. Okay, so I'm going to stop there. And if you have some questions, I'll do my best to.
Really, really good. Really good, Mike. I really appreciate that. I would, just for discussion, challenge your foundations
Okay,
for soil science. I'm thinking the foundations are chemistry, physics, and biology, and the morphology and genesis are outcomes of those basic sciences.
I appreciate that. I appreciate that idea, and I think it's worthy of discussion. I think that, yes, basic chemistry, physics, biology, they're outside of soil science. Or we take from those disciplines foundations for soil science. But what we take from those disciplines don't mean anything until they join in a morphology. If I'm studying a soil, I need to decide what is the soil, what is not a soil, and that is determined by its morphology. I almost would argue to leave out the word genesis and just go with morphology as a foundation of soil science, because the chemistry, all the chemical processes, the biological processes, the physical processes function in a context, in a spatial and temporal context that is defined by the organization of the mass and organization of the energy. I agree with what you're saying. I know, and I agree that, you know, outside of soils, chemistry, physics, biology are foundational, of course. But we perceive them in soil science through the context of morphology, I think. Or if we don't perceive them in the context of morphology, we're missing a whole lot. I'll put it that way. So what I've said, it could easily be, we could carry on a discussion for a long time, but it's something to think about. And I appreciate your bringing that idea up.
You spoke quite a lot about your connection to a place and to a home place. And I'm wondering how that's evolved for you throughout your career as you've moved away from that home place that your grandparents and parents lived in. And do you still see yourself as from there, or has it broadened to more from the Midwest? Or how does that evolve as you've had your international experiences and moving away from your traditional family home?
Well, I still think of that place as my home. Our family does not own that property any longer. When I graduated from college, I did not intend to go to graduate school. I'm not going to answer your question. I'm going to go off on another story. I did not intend to go to graduate school. I moved to the farm to live with my grandmother because my intent was to stay there and continue the farm. For a variety of reasons that didn't work out. And graduate school was the second choice. So I've certainly still kept a connection there. My mother and father are buried there. My grandparents are buried there. So I'm still connected to that place, but I hope I have also expanded my connection to many other parts of the world it's not the same as that place in my heart, but yeah, I'm trying to connect to other parts of the world too, and other people.
We have a question online. So Hyungji Song asks, states, I am a postdoctoral researcher. I am sometimes blocked by my limited knowledge. How can I expand my background?
Well, that's a pretty general question, so I'll give a general answer, I guess. I think read expansively. Don't just read about things that your research focuses you on, but read expansively the literature. Meet new people. Be open to new ideas and new kinds of projects. You can see that over the time that I have been here at Iowa State, I have worked on many different kinds of soil science projects, many different projects. If I had focused very, very narrowly just on frangipans, for example,
Microbiology of fragile.
yeah, if I had done that for 40 years, it would have been a disaster. So I think staying open to new ideas is really the key answer to that question. At least that's my answer at this moment. Yeah, Walter?
Dr. Thompson, oh my goodness, I love the story. I'm so honored to have attended your talk. As you're showing those pictures, the microscopic images, I was writing this. I said, inside the soil at the microscopic level lies the universe as it is inside a cell, human, plant, snake. Are we in alignment? Do you see things that way?
Yes, of course. Yeah, you know, I used to, when I did teach morphology and genesis, I would begin each semester by saying to the students, the most important word you're going to hear this semester is not the word soil. It's the word scale. Because everything that we are going to talk about in this course depends on the scale of our observations. And what I hope to do is in the course would be to help students connect the scales, connect that micro scale that I was showing in those pictures to the landscape scale in a spatial sense, to connect events that occur over a few seconds in the soil to events that occur over millennia in the soil. So expanding and seeing the connections of scales is, I think, super important. And that allows us to make the connections that soils have with all the other things like plants and roots and people and cities and valleys and all that other stuff. So yes.
Mike, I appreciate the talk today very much, and I've appreciated you from the first day that we met back in the 1980s. And I really appreciate your contributions, your thinking, philosophy, and everything. Just two specific comments. Beauty. So glad you talk about beauty. So many of us, we forget about beauty in our science work. I just want to add one, in addition to the sensory beauty that you focus on today, you know, some people that do theory and mathematics, there's a real beauty in mathematically, you know, capturing, you know, some of the processes or whatever on soil. We could talk a long time, but I had a lot of discussions with Don Kirkham about this early in my career. The second thing, I'm grateful you didn't spend much time on it, but you did allude to your family religious connection, religious belief, and motivation towards science. And somehow in our culture these days, there's somehow a thought that religion or faith and science contradict each other. Whereas some of the, early scientists, how our sciences developed were people of deep faith. And somehow talking about, again, openly, the connections and the strength of seeing that faith and reason do not contradict, but they go together is very important. So I'm glad that you mentioned, at least alluded to that in your talk.
Thank you very much, Bob. I appreciate that. And for those of you who haven't been around in the department for 10 or 15 years or so, how long ago was it? Was it 2010 or something like that? It's been at least 10 years since I gave a talk in the seminar series on science and religion, in which I basically said it's two sides of the same coin. And if you're interested in knowing more of my philosophy about science and religion, I'd be glad to share that talk from a long time ago too. So I appreciate your bringing that up, Bob. I completely agree with what you're saying.
We can keep asking questions. I'm going to remind people, it is slightly after the class is over. So if you need to leave, Dr. Thompson will understand, I'll understand, but I'd love to continue the discussion.
And I'll answer one last question from online. From Mary Tiedman, she asks, are there any soil science topics that you believe deserve more attention than are currently or historically receiving?
Are there topics that deserve more attention? Soil science topics that deserve more attention.
Correct.
Yeah, I think maybe deserve more appreciation. I'll change the question a little bit. We have many new tools in soil science, which are wonderful new tools that we didn't used to have. And I'm thinking of, for example, Bradley, the kinds of things that you do, the statistical tools, the digital tools, the ways in which we can assess soil properties over large scales relatively easily and turn that into useful knowledge. We have tools like isotope ratio mass specs that will allow us to track classes of molecules or even individual molecules through a soil. A lot of what I see in the literature today uses those new tools. I'm going to make a horrible generalization here, but to reinvent the wheel. And if I had my druthers, I would like to see everybody include in their scientific papers not just the classification of the soil, which is vital but often not included in the paper, but the basic morphology of the soil and the position of the soil on the landscape that they're studying and how it connects to other soils on the landscape. So it's, I guess, to get back to Mary's question, if I can, what's missing, I think, is kind of the basic the basic soil science of context for a particular study, as opposed to chasing something interesting with new tools. So I haven't answered the question about topics. What topics do I think might be neglected? Well, okay, I think pedological topics are neglected. How soils are transformed from over time. How soils are transformed over time under different climatic regimes, for example. But there are so many new applications that we also need to look at. For example, I think one of the next really important things for us as soil scientists is going to be a big emphasis on urban soils. Since so much of humanity now lives in urban areas, and yet there's plenty of soil there that needs to be managed effectively for to ensure human health in cities. So maybe that's one thing that I think will be more and more important over time. Yes, sir.
So growing up and then having the connection for soils, did you observe any practices in those days by farmers which has negatively impacted our soil's productivity today, besides climate change impact on production? And secondly, do you think there is something we are currently doing that will impact soils for our next generation crop productions?
Well, I think I can answer both questions with one answer. I think the most significant thing that farmers are doing that negatively impacts soils is our practices promote too much erosion. I think erosion is, there are many issues that agriculture creates and long-term sustainability of soils, but I think erosion remains the most important one. And so if we can find ways to limit erosion by, for example, having more perennials on the landscape, perennials that are crops we are producing for the betterment of humankind, but still crops that can prevent erosion and displacement of the soil in place. I think that would be the number one thing for us to do. There are many other answers to that question too, but that's at the top of my list, I guess.
You know, there are still more questions, but we've been in the room long enough. Let's thank Dr. Thompson again. Thank you. Next week, our seminar will continue with Dr. Robert Horton. So we're going to hear about clearing soil physics and what he speaks to about our future. Thank you.